The quadratic equation we're going to be looking at is a factored form. And the factored form is in the form f of x equals a, or a is always in the front, x minus r1, x minus r2. Okay. And like before, ladies and gentlemen, a tells us if it's concave, up or down. So it's concavity. Okay. Remember, if it's positive, it's up. But if it's negative, it is concave down. Another thing that a factored form tells us, ladies and gentlemen, is the x-intercepts with R1 and R2. R1 and R2 are the x-intercepts. So if we look at this, ladies and gentlemen, let's look at an example of this. I'm going to go and do an example with the following. So here we have f of x equals negative 2, x minus 5, and x plus 4. And what we see here, ladies and gentlemen, is that we already have a concave down. Now let's look at this. Let's compare it to the standard, right? F of x equals a, x minus r1, x minus r2. Okay. So here, ladies and gentlemen, we notice that a is negative 2. So it's concave down. We have to be very careful here, though, ladies and gentlemen. You think r is negative 5. But it's always the opposite, because keep in mind the minus sign here and the minus sign there. I know it's very confusing, guys. R1 is going to be opposite. R1, even though it looks like negative 5, it's positive 5. R2, these are opposite. Now the reason it's opposite is because it's minus sign. It's going to be a huge difference. So R2, even though it looks like it's positive 4, it's actually in fact negative 4. Keep in mind the way it is written. Minus, this is plus, so you have to change the sign. Okay. Again, R1 and R2 will always be opposite of what is shown. Now, if we were to go ahead and graph this, you guys, we can use a little bit of information that we have. We know it's going to cross at negative 4. 1, 2, 3, negative 4. And we know it's going to cross at positive 5. 1, 2, 3, 4, positive 5. And it opens downward, ladies and gentlemen. Okay. Once again, do not forget it's concave down. So it's going to open down. Like such.